2025. My name is HARIRAM Subramanian. I'm working for Huawei in Germany with the Competence Center for Power Electronics. A brief introduction about me. After I finished my electrical engineering, I worked in a variety of topics related to power supply, UPS, and then to PV and related topics on PV like grid code compliance and large-scale utility applications with PV inverters. So I have a technical background, and I'm working with Huawei for around about 5 years now. And I have taken a variety of roles in product management, and now I am leading the European solutions for large-scale PV applications. I'm glad to share some thoughts and ideas on the roadmap of how the PV will look like in the future. A brief introduction about our Competence Center and what we do on the R&D in Europe. The goal of our R&D activities in Europe is to create joint value. We are working with a variety of industry partners, technical companies, research institutes, and we collaborate in the European level to bring in quite a lot of ideas and bring these ideas for applications into a variety of solutions. We have a lot of technical experts in Europe working on from fundamental research topics to a variety of application topics. We are actively participating in creating knowledge through publications, working on research activities to create next generation solutions that will go into the product development. We are investing a lot also in European universities, research institute and enterprises, and also bringing up knowledge on creating new ideas and values together with our stakeholders in Europe. And as a brief introduction, going into our domain of PV application, I would like to share some ideas on what we started in the R&D activities in Europe. And what is extremely interesting is the establishment of Nuremberg Center, as you can see in 2011, where we started to create R&D activities, and we provide solution competency from this center in Nuremberg. And it has everything to do with power electronics and related applications on power systems and energy divisions for technological development activities. From the digital power perspective, where we are actually focusing on, we have 5 different topics. One is actually about telecom power facilities and telecom solutions, and then data center facilities and data center solutions for large-scale distributed data centers, and then smart PV application. That would be the topic that we will focus today, and Empower, which is on the mobility activities and electromobility related to vehicle management, battery management, and V2X and related topics, and then embedded power, which is actually modular power supply related solution that is coming under the gamut of the digital power activities that we are doing globally and also in our location in Germany. So our research center is located distributed around the world. One key center, as I said, is the Nuremberg in Germany. And I will go through very briefly on what we are doing here to get an idea on the activities that we work on digital power solutions, especially related to PV applications in Germany. And then we will talk about the trends afterwards. The Competence Center for Power Electronics in Nuremberg was established as a technological development center focusing on 3 activities. One is energy efficiency, integration, and miniaturization. We are actually having different working groups and different technical teams working not only on PV related topics, but also on UPS, onboard power supply, and components related to UPS. So we are also having established laboratory here where we are able to provide product demonstration, proof of concept, and also do some tests and help our customers do witness testing activities. And in addition to this testing activity, we also have a customer experience center where we conduct regular training activities, and we are also showcasing our latest solution and products and innovation in the customer experience center. This is also a location to perform integration activities and integration tests with different third-party applications and solutions. In addition to those activities, we are having membership in variety of technical committees, and we do joint work together with our colleagues distributed around the world. and we are also one of the key patent activities are being done actually also here in Germany. In Nuremberg, we have for the PV application a POC, testing and a verification lab. So this is a proof of concept testing. We are planning to get also some accreditation very soon for this testing lab. Here we are able to perform a variety of standard tests for the products like efficiency test, MPP testing, temperature, hotspot identification, working of the inverter system under harmonics. For example, grid harmonics are at high impedance. And we are also able to perform integration and perform monitoring applications for SCADA activities here. In this gamut of work that we provide, three important activities are core. One is the solution competence, another one is power systems, that is the interaction of PV inverters in the grid, and then is the PV inverter systems, which is actually going into the component level topology and magnetics, and also in control algorithms, for example. As I said before, we have actually around about 1 megawatt of testing area here, connected 20 kV in the network, and this system facility is also able to be expanded up to 2 megawatt if it is needed for the future applications. As many might have known or read in the news or articles in technical journals about our 10 trends that we actually set in some months before. So these are very interesting topics. We will go through these topics one by one. What are these trends? And we will also take a look into how these trends are converging more into the digital technologies for a variety of applications and a variety of benefits that will bring into large scale as well as commercial residential PV applications actually. So as the first trend, what we actually mentioned was the digitalization. We would see quite a lot of digital plants very soon. So what are these digital plants? So what exactly this means? So we would see more and more intelligence into some devices, more and more intelligence will go into some components, and this will be effectively useful for a lot of O&M, asset management, and also for looking into the data, checking into, let's say, the assets performance and so on. So we think by around 2025, 90% of the PV plants globally will become digitalized fully. So this means there's going to be quite a lot of Internet of Things, a lot of data transfer and communication activities that will bring in effectively a very simple, intelligent, and efficient PV plant. And I think this would be our first trend that we are actually thinking that will happen around about 2025, and the trend and the tendency is going high. And we're also seeing quite a lot of our digital customers right now going into this trend in a full pace. And the second is the AI-driven upgrades. So this is very interesting and very important. Also, we will see how AI and digitalizations are merging together. With AI, we will see actually interesting infinite possibilities. So AI are nothing but deep learning algorithms and pattern matching, and there are different kind of methods there which are used not only for system design optimization, but it could also use for diagnostics, looking into the lifetime through better analysis, etc. here. And we will see that AI would need quite a lot of computation power, and also a lot of data that comes through the digitalization needs to be analyzed, and this data needs to be then evaluated, and some kind of, let's say, an outcome should be predicted, and also a trend needs to be calculated. So in these activities, we see AI-driven upgrades will happen, and we might see that around about 70% of the PV plants will adopt these AI technologies. We also see quite a lot of innovative companies working on these activities, and we think this will go and merge into this kind of solution. So that we will call it as the put together of digitalization and AI. So we will have a lot of, let's say, devices which were actually very passive before to become more digital, and these digital devices will get networked, and then this network will also have some intelligent data analysis, and this might be very useful for O&M activities, will be very effective for maintenance, as well as look into the power plant very, very deep inside to understand the performance and to see optimization possibilities for this power plant or also for the future power plants. And then an interesting trend that we will see, around 80% of the power plants will happen to become unmanned. Most of the power plants are being built in very remote locations and in extreme difficult terrain, for example. So these power plants, once it is constructed in these terrains, needs to be monitored and managed and also checked for the performance. And obviously, utilizing the digital aspects and the AI aspects, we will see that there would be quite a lot of unmanned PV plants. And so this is also the trend. And this means using robots and using unmanned drones, and also using machine vision and some kind of special technologies. And even we are looking into activities like digital twin in these kind of systems. We will see this kind of unmanned power plants very soon by 2025. One very important trend, this should be a key trend because of a lot of penetration of renewables into the grid and disconnection of classical rotating machines from the grid. What is very important is to have the grid friendliness through power electronics based technologies, or we call it as a proactive support of power grids. We are also seeing a trend in some regions where the short circuit ratio is going down. So that means the system could be very weak, the power system and so on. And we are also looking into the happenings where there are quite a lot of DC connections, HVDC happening. And we are also seeing that there will be high amount of power electronic penetration. That means there isn't any inertia, there isn't any rotating mass. And so these are bringing different set of challenges for the power grid and for the systems when power electronics will be penetrating. So that brings into quite a lot of topics related to stability, quite a lot of topics related, let's say, to harmonic suppression, and also some kind of damping requirements and so on. And these are some of the very important activities. So we will see that in the future, that most of the technology that we are talking now, like grid following, or let's say as inverter as a current source, will be looked upon mainly as a voltage source, or it will do more grid supporting activities. So we will see that there will be more of grid forming kind of inverters that are needed to be deployed in very weak situations. And also this would mean that a different kind of control application, different type of testing, and this would help inverter based technology to penetrate into quite a lot of challenging situations. The trend 5 is actually very interesting. It's already happening. Everybody is talking now. It's a storage and solar integration. So we will see that the storage will exceed around about 30% by 2025. This is happening because of lower cost of cells in production, and also there is a very high optimization that has taken place in the battery technologies. And then we will also see quite a lot of important electronics around the battery technologies for cell balancing, for battery management, and so on. And also what is very important is not just in the utility scale, but also in the residential and the C&I applications, where we will see storage taking a very important role. And also storage will participate into one other important activities, like going into the balancing market through virtual power plants and so on. So we see this is very important, and it's also going in the right direction to bring in let's say the green technologies to the forefront. So as I talked about the balancing market with storage, is important topic is the virtual power plants, that we call it as the trend 6. We will see not only in Europe, but also a variety of other regions outside Europe to have virtual power plants or aggregation of power plants, which will also enable even small power generation unit and small market participants to join into the big PV market, and also bring them to the exchange for the energy between these kind of markets and end customers. So we will see all these prosumers will be joining this VPP, and with the VPP there would be quite a lot of interesting activities that will happen because you are more distributed, not centralized. And this brings also a part in the data transfer, real-time data, and this will create not just data models, but also business models as well as there would be quite a lot of power flow, which will be very different to the standard centralized power flow, these kind of things. And we will also see some interesting activities in the VPP through blockchain and also through cloud applications on hosting these kind of power plants. And so these are actually a very interesting trend to watch, and also to see where quite a lot of participants will be enabled to join into the market actually. And another very important topic is quite currently being catched upon is safety applications. So we call it as everything that has to do with the safety related topic. One important topic is actually arc fault circuit interruption. For example, there might be in a case on the rooftop installation kind of a DC arc, parallel arc, serial arc, etc. And these are some of the things that will be, let's say, quite a topic for insurance companies or also for the asset owners. And we see that this kind of active safety is getting more and more important in C&I and residential applications worldwide. So these kind of trends, we are also bringing in technologies here for AFCI, arc fault circuit interrupters, where we wanted to avoid nuisance tripping and so on, and bringing more robustness in terms of detection if there is a fault. I think this is an activity also to look into the C&I and residential segment that will happen, and it's also happening in Europe in a variety of locations. From the technology development perspective, I think this is a very important topic that is going into high power density. So high power density means going into different technology to have higher switching frequencies, and also bringing in activities through these high switching frequencies, getting benefit of new semiconductor technology like silicon carbide and gallium nitride components to actually bring in high kilowatt per kilogram, or to increase the density in kilowatt per liter actually. So this brings in also an interesting aspect, not just in the semiconductor, but also in the packaging, because there might be quite a lot of passive components that will be integrated into the semiconductor packages, like gate drivers and other passive components like capacitors and so on. And so this is going to bring in high amounts of reliability in the power conversion technology, the process, as well as bring in advantages in terms of heat dissipation, and also bring in the concept that we will see later, which is the modularity. So we think around 2025, power density will be extremely improved, as you are seeing even right now, around 185 kilowatt inverter having around 183 kilograms. So that is actually showing high level of integration here and high level of power density in the products. And we will see that also in the future in the trends coming up in the power electronics. So from there, when we extrapolate, I think what is interesting is to see the modularity in the design. So modularity is also bringing quite a lot of benefits for the plant owners, that it brings in different application scenarios, standard interfaces, hot swapping methods, also flexible deployment, and it is also bringing in easy maintenance in case of needed on some components and some kind of systems, so that there is not a necessity to have expert on site to do maintenance in case it is needed, and also the availability and the reliability of the power plant system is kept quite high. So this is a combination trend that we can see with high power density, modularity. We can even think of small kind of packets of power electronic modules that could be integrating, and different types of flexibility in the design can happen through this kind of modular designs. And we will see it not just for the solar inverter part, but also for the storage part and for the power conversion unit that will be used for the storage related activities here. The last trend actually is very important and very key. Also, standardization is going into this kind of topics. This is related to security and trustworthiness. Because the power plant is one of the critical plant, it is mission critical application actually when a lot of renewables penetrate, and this needs to be safe, secure, and also resilience against external events and activities from externalities. So that is very important. We will see quite a lot of, let's say, reliability improvements, security improvements, resilient improvements here. But at the same time, also data use and compliance is very critical when virtual power plants will be working, and when we'll see different kind of technology, digital technology that will take place, data security is very key, and also what is important is verifiable, trustworthy, and high reliability system here. So these are very important activities that we will see, and it's already very important. It's not that you have to wait till the next years to come. These are some of the activities that is actually gaining pace now and being worked upon in variety of stakeholders in the PV domain. So saying, we wanted to thank you everyone for listening to this and also understand what we are actually contributing, what we are actually working on in terms of digital technologies, especially in application related to power supplies, for PV related topics. And we would be very happy to host you also in any time when you are visiting our office in Germany or in Europe sometime. And maybe the next time we will meet face to face, because this one we are doing virtually. But we are more than happy to get connected with everyone. And if you're having any questions or any kind of comments, please do share with us. And we are more than happy to take your feedback. And thanks for joining and thanks for listening to this virtual session. Thank you very much.